Okay, so yeah. So today we're going to start with optimizing 2D shapes. Okay, so we're going to work with area and perimeter because 2D shape deals with area and perimeter. What does the word optimizing mean? When I say I'm optimizing something, what does it mean? Maximum?
It's not like 100%.
So optimizing is actually maximum or minimum, right? So when I'm optimizing something, I'm either trying to maximizing something or minimizing something, okay? So let's say you have a piece of land and you want to fence it, right? And you want to know how much perimeter do you need? How much fencing do you need, right? Do you want to pay too much for the fencing or do you want to try to minimize the fencing? Minimize the fencing, right? So you're going to have to figure out a way that you're going to fence it where you're minimizing how much fencing you need, right? But you want to plant lots of trees. Do you want to maximize your area or minimize your area? Maximize your area. So optimization is you're trying to maximize your area and minimizing your perimeter. Okay? Because perimeter, you need actual material to fence it or whatever, right? Even when you're talking about a cup or when you're talking about making a binder, right? They try to maximize the area, minimize the perimeter. Because the perimeter means material that we are using to make it. So in this case, we have Abby. Abby is our dog, our class dog, and we want to build a fence for her. Okay, we want to build a rectangular pen for her. You are given a set amount of fencing. Okay, so that means my perimeter is set. And we're trying to optimize the area. When I'm saying I'm saying I need to maximize. Okay? What do you want to optimize the area for, Abby?
So the dog has something.
Sorry, I did not hear what you said.
The dog has something to run.
So the dog has more area to run, right?
Minimizing the perimeter.
Okay. So to give Abby the largest possible area to play. Now, let's say you are given 12 meters of fence, okay? And you want to draw a picture of the area that Abby's gonna play in. So can you guys give me a rectangular area, a rectangular shape that will give you 12 meters of perimeter?
3, 4.
Perimeter. What's the formula for perimeter?
8 by 8. No, 4 by 4 by 4.
4 by 4 by 4 by 4? That would be 16.
Perimeter is plus.
So if I'm drawing a rectangular area here, and I want my perimeter to be,
So you 4, 4, 2, and 2, right?
so you want to do 4, sorry, so 2, 4, 2, 4, okay? Right? 4 and 4 gives me 8, 8 and 4 gives me 12, right? So my perimeter here is 12, okay? Can you guys, so let's fill this out. So perimeter is 12, dimension is 4 by 2. What would my area be here? What would my area be?
It's 8.
It's area.
Yeah, 4 by.
Good. Now this is one example that I can use. So I can use my 12-meter fence to make a 4x2 rectangular, right? Rectangle for Abby to play. Can you guys give me another example that will make up 12 meters?
No, no, 2.
3. So what would it be? 3 and
3 by 3.
okay. So I have 3 by 3 by 3 by 2, right?
Oh.
So the dimension here would be 3 by 3. What would my area be?
9.
Okay. Give me one more example. Yeah, 1, 1, and 1.
5, 5.
Okay, 1, 1, 5, 5, right? If I add all the perimeter, it will give me all the sides, it will give me 12 meters. My dimension is 5 by 1. What's my area?
5.
5. Because 5 times 1 is 5. Okay, now looking at these, which dimension gives me the largest area?
2 by 4.
The largest area.
3 by 3.
3 by 3. Right? Okay. Okay. So we've seen 3 different examples, right? We've made 3 different shapes, 2 rectangles and a square, and then we determined that the 3 by 3 gives me the largest area. Can I move on to the next page? Can you write later on? Okay. Now I have 16-meter fence. 16. So I can make 4 by 4 by 4 by 4, okay? That gives me 16, right? 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. What would be my dimension? My dimension is 4 by 4. And what's my area? 16 meter square. Give me another dimension. 5, 5, 3, 3. Okay.
Remember, you're doing it again on the chart, you're trying to show the whole thing. Remember how we
So dimension is 5 by 3. What's my area?
Even though some of the numbers are high, here with 144.
Meters.
You don't have to
6, 6.
do it again.
Okay. So it gives me 8 plus 8, that's 16.
I know that goes beyond. But let me read this out.
And that would be
first.
4 meters square. Mhm.
But you should understand it, don't just copy it. Yeah, no, I'm gonna erase it out.
And
Don't.
my area is 7 meters square. So which one of these gives me the largest area? So the 4 by 4. Have you guys noticed anything?
Yes.
What?
When we have long side, we cannot have a small area.
So if I have like the sides here 5 and 3, right? They're kind of close to each other. But do they give me the greatest area? What shape? What kind of shape do I have that gives me the maximum area? S square. S square. And this is where it's always going to work. Okay? If you don't have any restriction, we're going to talk about restriction later on. But if I don't have any restrictions and I'm trying to build a square or a rectangular shape, the square will give me the maximum area and the minimum perimeter. So this right here is a similar example. We're just going to use. So you guys have already figured out the pattern here. Which is great. What other than 5 by 5?
4 by 7.
Okay, then 3 by 7.
Quadratic or quadratic. And 1, 2. You just answered them. Oh. That's what I thought. Yeah, my, I that was, I was more comfortable. We did that way back. But I learned about it. That's why I didn't realize it. That's why we're going to do straight there.
Okay, so again, this is another example that shows that a square would give me the maximum area, right? 5 by 5, gives me 25 meters squared. Okay, can I move on? So the answer would be 5 by 5, and that gives an optimal area of 25 meters squared. Now, this time, your dog Abby has trampled your garden and destroyed all of your award-winning pumpkins. You need to rebuild the garden, keeping the area set at 36 meters squared. But this time, you are going to build a fence to keep Abby out. You need to determine the amount of fencing required to optimize the perimeter of the garden. So the question to you is, why would you want to optimize perimeter? Plus,
I need to buy something, right?
that's right, you need to buy the fence. Yeah.
So if they have less
Perimeter.
perimeter, so I will have less money to spend.
That's right. That's right. Right? So the perimeter needs materials, right? To buy the material, the lower the material you have, the less cost it costs you, right? So you're trying to minimize, right? When we say optimize perimeter, we actually mean minimize the perimeter. Right? So I'm using less material, that means I'm spending less money. Okay? So just so you guys understand this, it's you're trying when you're trying to find the perimeter, right, we are given a set area, right? The area is given to you. In the previous examples, what we have done, they gave us a set perimeter and we're trying to maximize the area, okay? So there's always something set given to you. So, an area of 36 meters squared. Give me dimensions that give me an area of 36. No, just give me, I'm gonna have 5 examples. 6 times 8 times 4.
6 by 6 by 6.
So 6 times 6, 8 by 4, what else?
5 by 5.
5 by 5 give me 25, not 36.
Oh, you want just 36?
Yeah, because the area, now my area is 36.
6 by 6, 0. No.
So, let's draw the ones that we already know. 6. What would be my perimeter if I have 6 by 6? What would be my perimeter? Perimeter.
24.
What would be my unit? No, just meters.
Oh, just
Okay? So that's one example. You guys told me 4 by 9, right? So 4 times 9 gives me 36, right? What would be my perimeter here? 4 plus 4 is 8. 9 plus 9 is 18. What's 8 plus 18?
26.
Meter, right? Another one would be 3 times 12. Right? Because 3 times 12 gives me 36.
So should I separate each one?
What would be my perimeter here? So 3 plus 3 is 6.
30.
6 plus 24 is 30. Then I will have 2 by
16.
2 by 18 gives me 36. 18 plus 18 is 36. 36 plus 4, that's 40 meters. Anyone doesn't know what was happening here? What? We're trying to find dimensions that if I multiply them, it gives me 36. Okay? So 6 by 6 gives me 36. Okay. This one? You add all of the sides. So 6 plus 6 plus 6 plus 6.
Oh, we added. Okay.
4 plus 9 plus 4 plus 9. If I have a side of 1, what would be my other side? To give me an area of 36.
So 36.
Oh, that's why you know.
So what would be my perimeter?
36.
Okay.
Do all your dots first.
Okay? So 36 plus 36, that's 72. Plus 1 plus 1, that's 72.
Everything.
So what can you guys tell me? Which one gives me the minimum perimeter?
Just do a very,
Six by
very
six.
trace.
When has it?
6 by 6.
And I can tell from this point here to this point here that it's beyond, it's gonna be a very, very slight incline.
So, again, the square is winning.
Now mind you, I have decent marking solve density. So, what was your next point?
So what can you conclude about optimizing area given a set perimeter?
Because it's just a point to this three actual Oh, yes. So,
What can you tell me? What did we learn? What does optimizing area mean?
They give you the maximum or minimum you have the next
When I'm talking about area, is it maximum or minimum?
maximum.
Maximum.
oh, okay, so this is going to be a line that you can barely see. So you're not going to be able to see this. It's going to be here. So that's why I put 6, right? We had one there. That was, I did it.
What shape is it?
Square. But if they all have x, it'll be x2. It's in the next two, it's next to
Let me check something.
next to next to next four. So
Yeah.
what's happening is basically.
Yeah, you're right.
Now, what formula would I use for an area of a square and a perimeter of a square?
So remember.
So for a rectangle, it's length times width, right? But for a square, the length is the same.
For,
Axis.
That's for the perimeter.
pyramid,
Yeah.
yes. For the area and, carry.
Else,
Is it?
you need me? Okay, just one
I
second.
was looking at mine.
So for the area, it would be L squared. And for the perimeter, it would be 4L because it's L plus L plus L plus L. So that gives me 4L.
Exactly, just to show.
So these are the formulas that we're going to use when we are maximizing or minimizing areas.
And that's what I'm doing with the numbers.
Hey.
Yes. No, up to that.
Even if you're sure.
Yes. Exactly.
Okay.
And remember, the reason why I predicted.
So let's try to answer the next part.
I literally saw my picture and like zoom out. That's what I did in my head. I was like, no, draw the numbers wider so I can show my work. And that's what I did.
So what can we conclude about optimizing perimeter?
So when you're joining everything, it's just done. Oh,
See, I don't know, I didn't do that one, but that was.
Given a set area. So what does the word optimizing perimeter mean?
Minimize.
Much smaller.
Yeah. Yep. Exactly. What were those inversions just now? Wow.
What's the shape?
Rectangle.
Oh, wow. No, I just saw everything.
So it's a square. And again, the formulas are still the same, so A equals L squared and B equals 4L. Now, something that I want you to remember. When we are given the area, you're gonna start with the formula of the area, okay? So first thing you're gonna do, you're gonna start with the formula of the area. You're gonna solve for L, and then you're gonna use the formula for the perimeter to find your minimum perimeter. Because the area is given to you, so you must start with the area. When we have the perimeter, when the perimeter is given to us, if the perimeter is given to us, we have to start with the perimeter formula, solve for L, then use it to find the area. Okay? We're gonna look at some examples. So let's look at this. So without drawing the rectangular enclosures, use what you have learned about above to determine the optimal area perimeter for problems. Guys, your voice is higher than mine. I'm trying to scream here. So, if your perimeter is 100, so what formula do I start with?
To find
No, you don't start with area. What do you start
we
with?
do the perimeter.
That's right. You start with the perimeter.
Yes.
The perimeter is given to you, so you have to start with the perimeter formula.
Yeah.
Oh.
Right?
Find the area.
So when you have perimeter, you have to start with the perimeter.
That's
But
right.
when you have area, you have to start with the area.
That's right. So, I know that the perimeter is 100, so I can replace the P with 100.
And it's 25.
And I need to solve for L.
It's 25.
So I know that my side length is 25. Right? So the question is asking you to determine the optimal area for perimeter. So if I want to find my optimal area, what do I do?
25 plus 25.
So 25 square.
4L.
625.
Are you guys okay with this? Now, what if I'm given an area of 49 meters squared? What do I have to do?
Area.
Start with the
Area.
So what's the formula for the area?
A is equal to
L square equal to 49.
So I can replace the A with 49.
Yeah, and you have to find meter.
Now, how would I solve for L given 49 equals L squared? Square root.
Seven.
Right? To get rid of a square, I square root.
Wow.
So, L equals to 7. Now, L equals to 7 to find my perimeter is 4 times L.
20.
Okay? So what's going to happen right now, I want you guys to try the other 4 questions. Okay? And then we should have time to do optimizing with restriction. I will decide in about 5 minutes. Okay?